Okay, everybody. This video should be relatively short. We're going to talk about a little bit more about functions. And before I dive too far into it, I realized that I don't think I talked about intercepts in the last video. So I just want to make sure we all understand how intercepts work. And that is that whenever you see a graph, you have the x-axis, which is your horizontal, and the y-axis, which is your vertical. And as you see a graph do something like this, and I'm not too worried about where the numbers fall here, so I'm just going to make it like 2 up on the y-axis, -2 on the x-axis. Here's a 1, here's a 2, and this one we're going to say it crosses at 3. Okay. So intercepts are the locations where a graph crosses one of the axes. So an x-intercept is where the graph crosses the x-axis. Okay, let me do that so I don't run into my own graph. So on the x-axis, I have 3 x-intercepts, one here at -2, one here at 1, and one here at 3. And what you'll notice is that sometimes in your homework, it'll ask you for the x value, when sometimes it will ask you for the point. So if I'm asked for the x values here, I've got a -2, I've got a 1, and I've got a 3. So those are my x values where I have x-intercepts. Okay, so that's all great. But sometimes they'll ask me for the actual point where there is an x-intercept. So their points here are, if we think about it, these are the x values. So points are always x and then y. So for this point, my x value is -2 and my y value is 0 because I'm not going up or down any, right? So I've got -2, 0. I've got 1, 0. And I've got 3. Oops, I'm so sorry. 3, 0. There we go. There's my ordered pair. Okay. And what we notice about this is the y is always 0 in an x-intercept. So later, whenever we're asked to find x-intercepts, what we're going to do if we don't have the graph is, if we have the function, we will plug in y equals 0, and that will help us to find our x-intercept. So that would actually look something like, you've got an equation, I'm just going to make one up for this guy, x cubed minus 5 equals 0. If we set it equal to 0, this would be my y value, right? Y equals, if I set that y equal to 0, then all I have to do is solve this guy and I will be able to find my x-intercepts, okay? Being able to factor, being able to use the quadratic formula, things like that will help me with this. This one's not so bad because I just put x cubed minus 5. I can move the 5 over and then take the cubed root of both sides and I can find those 3 solutions fairly quickly, okay? So that's what those look like, x-intercepts. So let's talk about y-intercepts. Y-intercepts occur where the graph crosses what? And in my head, I hear you saying where the graph crosses the y-axis. Absolutely. Okay, so again, this would happen right here. Assume that actually gets up to the 2. I'm sorry, my graph is kind of yucky. Okay, well, it's where the y is equal to 2. Well, what is the x there? Well, we didn't go left or right any. We stayed right here. So the x value here is 0. So the point is 0, 2. And if we have a function, by the way, we're only going to have at most one y-intercept, right? Because we can't cross the y-axis again, or we won't pass the vertical line test. So we only get one of those anytime, and that's only if it crosses the y-axis. I'm sorry. Notice that the x value is 0. 0 in the y-axis. I'm sorry, y-intercept. Okay, so above we had that the y value is always 0 in an x-intercept, and now we have that the x value is always 0 in a y-intercept. So that's just a given that we know in the background to keep up with. And later we'll be asked to find x-intercepts and y-intercepts. So I want to make sure everybody has seen that. Again, that's probably a bit of review for us, but hopefully it solidifies things for intercepts for us. Okay, so moving on into this section of your homework about more about functions. If you're in the Blitzer book, that's 2.2. We want to talk about even and odd functions. Okay, so even and odd functions. These actually there's rules for this as well. So let's take a look. Okay. What we're going to do is we're going to start out with something like f of x equals x plus 4. Okay. And what we're going to say is we're going to test for even or odd. To test for even or odd, what we're going to do is we're going to plug in a negative x. Okay, so that's important. What we're trying to see is if we plug in a negative value here, do I get the same thing out? Do I get the opposite out? Or do I get some weird thing out? So the answers are going to end up being even, odd, or neither. Okay, so if you get the same function, then we consider that even. If we get exactly the opposite, and that's the part we're going to have to watch out for, the exactly part, because sometimes some of our values will change and some of our values won't. But if we get exactly the opposite, then we have an odd function. Okay. And if it's something else, and I like to say those are the weird ones, but actually they happen more than you would think. I'm sorry, I'm off the page. If it's something else, something weird, then it is neither. Okay, so you get 3 choices here. So if I have this function, f of x equals x plus 4, and I want to check to see if it is even, odd, or neither, then what I'm going to do is everywhere I see an x up there, I'm going to plug in negative x. That's the test. The only thing you need to remember is plug in negative x. Okay, so whenever I go to work this out, I say, okay, well, negative x is negative x. If it was squared or something, we might get something different, but it's negative x. And then this didn't have an x value, so the plus 4 that stayed the same. So what we see is that this one right here was originally a positive x. Now it's a negative x. So this changed. Okay. Which would lean myself towards odd, except for this one was a plus 4 to begin with, and now it's still a plus 4. So this is the same. So what we have here is that one of my signs changed and one of the signs did not. Okay, so go back and look. If you get the same function, which is what happened here with the plus 4, that guy is even. If you got the opposite function, which is what happened here with the x, that guy is odd. But here for my entire function, I got one change and one same. So that's something else. That's something weird. Okay, this guy is a neither. Okay, so that's how I'm going to determine what I've got here. And we'll come back. I'll bring back up the how I know in a second. We're going to do another example. So here we go. My example now is, what if I had is f of x equals x squared minus 3, even, odd, or neither? That's the question. Okay. And hopefully you will say, well, to check for even, odd, or neither, I'm going to plug in negative x. Everywhere that, oops, sorry, that's a minus. Everywhere that there was an x in the original. So I'm going to find f of negative x. That means plugging in a negative x here and squaring it, okay, because the whole x is being squared. So this whole entire negative x is going to be squared, okay. And then the minus 3, that guy doesn't have an x value with it. So I'm going to just leave him alone and see what I get here, right? So this is equal to, what happens when I take a negative times a negative? A negative times a negative is a positive, right? So this becomes a positive x squared, okay? And then what about here? It's just minus 3 because nothing happened. I didn't plug anything in. So when I go back to look, I say, hey, the original guy was an x squared. After I plugged in negative x, I've got x squared, okay? And the original guy was a minus 3, and after I plugged in negative x, I got minus 3. Doesn't that look like it's exactly the same? Yes. This guy's the same, and this guy's the same. So since all of the terms in my function here are the same, then it's the same. So looking back at my little check, okay, plug in negative x, we did that. If you get the same function, it is even. So this guy is even. All right. So there's a little bit of a cheat here, and I can tell you what it is just by looking at this problem right here. And you can apply it to the last question I did also, and maybe it'll help you. Whenever I have a constant that doesn't have any x's with it, you can think, well, it's not x to the first, it's really x to the 0. Because x to the 0 is just a 1. 1 times 3 does not change anything. So that's the same as if I had an x to the 0 sitting out behind every single constant you see. And what do we see about x to the 0? The exponent. The exponent here, 0, is even, right? And 2 is even, okay? So if I have all even exponents, except for on the constants, but we can say, oh, it is even, right? Then the whole thing is even, and that's going to work out for me. On the last one we had, look here. What's the exponent up here? It's really x to the first, right? That guy's odd, okay? And if I use my little cheat I just showed you, x to the 0, which is really a 1, it doesn't change my value. That guy is even. So that should go with what we said here. Hey, look, this one changed. That was odd. This one stayed the same. That was even. So I have a combination of exponents here that are even and odd. That's why it's neither. Okay, so that should make sense, I hope. This one, though, I had x squared, which is even. And I had x to the 0, which is even. So I had an even and an even. All of my exponents are even. So I can kind of take a little cheat step and say they're both going to be the same because both of the exponents are the same. So the whole entire thing is even. Okay. So one more of these and then we'll kind of skip it a little bit. Well, maybe 2, I guess. I'm looking to see what I've got in my notes. How about if it was is f of x equal, this should have been is as well, is f of x equals x to the 3rd minus 2x, even, odd, or neither. Okay. So to check this, you have to plug in the negative x. So don't go, oh, I'm going to do the little shortcut. You can do the little shortcut and have a really great idea, of where you're headed, okay? For instance, this one's odd, right? This is 2x to the first, so that one's odd. So I think this whole thing's going to be odd. But to do this on a test, you have to show me the plug in negative x step, okay? So on a test, I want to see this because that's how I know if you understand the rule, okay? So show me that step, and then if you skip some steps, I'm okay with it. So negative x, it's going to be cubed, and then negative x, it's technically to the first, but I know I don't have to worry about that. So what happens if I have a negative times a negative times a negative? So it's 3 times here, right? Well, a negative times a negative is a positive, but when I throw in that third negative, I get negative. So negative times a negative times a negative. That's a negative, okay? And then here I've got a negative 2 times a negative x. Well, what happens when I do a negative times a negative? Well, that's a positive, right? Okay. So what happened? This guy originally was a positive. Now he's a negative. That's a change, right? This guy originally was a negative. Now he's a positive. That's also a change. So here I go. Both of my signs changed. The whole entire function is the exact opposite of what it started with. And when I go and I look again at my little check, okay, if you get exactly the opposite, then we have an odd function. So this guy is odd. Okay. So if you would like to try one more just on your own, I'm not going to do it here. Then my example for you to try, you can pause the video, whatever you want to do. That's fine. Is what if I had y equals x squared minus 2x plus 4. Okay. And if you're not sure, the y here is the exact same as if I had an f of x, right? The y takes the place of the f of x. You can do that and then plug in the negative x. And I'm going to tell you the answer is going to be neither. So do your work, push pause, plug in the negative x, come up with your answer, right? See what that does for you. I'm not going to work it all out. I'm telling you what the answer is. So I think y'all should be able to do that after what we just talked about. Okay. The next little piece in this particular section of material talks about symmetry. Okay. We have x-axis symmetry. Okay. Most of us have probably seen something like that before. These graphs are going to look like they are symmetric around the x-axis. Well, this is my x, this is my y. So something to this effect right here is symmetric around the x-axis. Here's the x-axis. Symmetric means if I fold it right here, fold the graph on top of itself, this piece here will come down on top of this piece exactly, right? That's x-axis symmetry, okay? So that's what it's going to look like. But real quickly, I'm going to ask you, is that guy a function? And hopefully you're thinking vertical line test. And the answer is no, that is not a function, right? So this is not going to work out for me. I'm not going to see it. Okay. So this guy is not going to be even or odd. He's not a function. Okay. The second one is y-axis symmetry. And this one we actually will deal with a lot. I'll draw his graph here. Y-axis is this one coming up in the middle, right? Here's my x, here's my y. So if I have some y-axis symmetry, that probably looks like something we've seen before, like a parabola. Or, oh, I'm sorry, that is a horrible graph. There we go. Okay, so y equals x squared. Or if I had some kind of something like this, okay? That would be some form of y equals x to the fourth. This is a different graph, sorry. I shouldn't have graphed them on the same. Let me try this over again. Let me put him over here. There we go. So you don't think those two graphs are on the same axis. Okay, this would be like y equals negative x to the fourth, okay, plus some stuff back there. Okay, but the idea here is, again, if I split this right down the middle, down the y-axis, if I folded that, ignore this down here, I'm sorry. If I folded this on the y-axis, then this piece on the right would fold over on top of this piece on the left. And same thing over here. If I fold it on the y-axis, then this piece over there should just lie nicely on top of that one, okay? So if you see that, ignore this piece down here, I'm so sorry. Then you know this is y-axis symmetry, okay? And it just so happens that this happens whenever you look at the exponents here, when we have even functions. Okay. So that's how you're gonna kind of see that and go, oh, okay, this, whenever I graph this even function, if I know it's even, then when I graph it, it's going to end up being y-axis symmetric, okay? That's how that works. And then the last one that we're gonna see here is symmetric around the origin. Origin symmetry. Okay, and this one looks a little bit unusual, so let me give you the graph for it, and I'll explain how the symmetry part here works. Okay, so these end up looking something like this. This is the most kind of common one that we see going on, and I'll give you his equation in a minute. But before I give you his equation, I want to show you what we mean by symmetry. Okay. So by symmetry, what we mean is it's around the origin. So here's the origin, that point 0, 0, right? Okay, the origin. And what we mean is if we pick up this piece on the top and we rotate it from here all the way over here, then it'll lie on top of this piece here. So make sure the curve works the same. So 2, 2, 2, 2, 2, 2, 2, 2, 2. We're going to move him over here. So it's rotate instead of fold like the others. It's rotate 180 degrees. Okay. Will this piece on the top end up down here lying on top of this piece down here? And the answer is yes. This one has origin symmetry. The way a lot of times we would look at this is to look at the equation. The equation here, you might not know him, but he is y equals x to the third. Okay. And so hopefully you see that 3 is an odd exponent there. And you go, oh, wow, this is origin symmetry. And so you go, he's an odd function. Okay, odd functions have origin symmetry. All right. So they don't have to look just like that. They can be bigger or whatever. So I can show stuff like this one. Here's my X. Here's my Y. What if he looked something like this? So this one's a little bit more tricky. So if I rotated everything 180 degrees, this little piece up here would end up down here on this little piece down here. And if I rotated this one 180 degrees, he would go like this. Let me give a 2, 2, 2, 2, 2, 2, 2. He would end up there. This piece ends up down there if I rotate him 180 degrees. Okay. So a lot of times people say, pick up that part, it doesn't matter which part. Okay. Pick up this part and rotate him 180 degrees and he will land right on top of that. Okay. So this one is also origin symmetry. Okay. And then we have some weird functions. Even if it's a function, it might still look unusual. So here's one right here. I'll give you a graph. What if it did something like this? Okay. And hopefully you're looking at that one going, well, that's not symmetric at all. And you're right. Okay. So this one is not symmetric. And if they are not symmetric, then they are certainly not even. That was the y-axis symmetry. They are certainly not odd. That was the origin symmetry. So these are neither. Okay, they're not even and they're not odd. They are neither. Okay. So you just have to look out for those kinds of things. Occasionally we get some weird functions out there just so that you can see one of them. What if I had y equals the absolute value of x? Okay. He's not necessarily one that we would say, like, what's his exponent? His exponent looks like a y, but or 1, which would be odd, but he's got these absolute values on him. So I'm going to have to actually use the honest to goodness f of x equals absolute value of x, the test f of, I'm going to plug in a negative x everywhere I see an x. Okay. And when you look at that, you go, oh, hang on. What happens when I put a negative inside of the absolute value? Well, absolute value means distance from 0, right? So the distance from a negative x is the same as a distance from a positive x. So the negative goes away and I just bump out or fall out. What falls out of the function is the absolute value of x. So this guy is actually even. Okay. And if you were to graph him, like on a graphing calculator or something like that, you would see that an absolute value, value, V stands for value, okay, y equals absolute value of x. That's what that graph looks like if you figure out how to graph that on your calculator, okay? So when I look at that graph, I say, oh, he has symmetry around the y-axis, right? If I folded this, this piece would fall over on top of this one. So again, you can see how these line up. So this is y-axis symmetry. And the function is even, okay? So hopefully that falls out for us, okay? The last piece in this section, I know it's kind of getting long. There were several things in here. The last piece that, well, there's one more little thing I'm going to throw out there at you, but the last piece that we're going to talk about in depth-ish is increase, decrease, and constant. And I am not going to beat this one into the ground. What I am going to say is that what you need to do is look at a function. Hang on just a second. What we need to do is look at a function and read it from left to right. So we always read left to right. And we tell increase or decrease or constant, but I'm not going to worry about constant right now, by looking at the x values. So we look left to right, and that means x values. If we were looking up and down, that would mean y values. Like when you're looking at a range, you're looking up and down, that is your y values. Domain, left to right, that is your x values. So I'm going to give us a graph here. Again, x and y, and my graph is going to look something like this. Okay, and we will just say that this is the point -4. This is the point, let's say, -2, and let's make this 3. Okay, this is the point 1. This is the point 2, -3. Okay, where this turns, and this goes all the way out to infinity, of course. Okay, so when I'm looking at this, I'm going to just kind of follow it with my pencil from left to right. Okay, so I say, okay, when I start here, are the y values increasing or decreasing? Well, here they're increasing, right? I'm going up. If you think in terms of slope, which we'll talk about soon, this slope is going up. So it is increasing from here all the way to here. So I'm going to put a little line so we see this is the segment here that we're going to talk about first, from here to here, okay? We're going to talk about it in terms of X, and we'll come back to that. But I want you to know that portion of the graph is increasing. Okay. Then what? From here to here, as I follow it with my pen, it looks like I'm coming down, right? Okay, so down is decreasing. A negative slope in this case is going to be decreasing. So that goes this section right here of the graph. I'm just kind of marking it off. In here, we're decreasing. Hope that makes sense. And then here from the x equals 2 out to infinity, this guy is sitting flat, right? And flat means constant. Okay. In other words, the slope's not increasing, the slope's not decreasing, it's just sitting there doing nothing. So that slope is constant. Okay. So as I look here, I say, okay, read it from left to right. So we're going to talk x values when we're talking increase and decrease. So my increase here, it's going up between what's the x value as this arrow goes down and over, down and over. Remember, arrows are forever. So this means forever, right? It's going down forever and it's going left forever. So on my left to right, I start way out here at negative infinity. Excuse me. And that goes up until what happens to my x value? This spot right here, what's the x value in that point? That point was negative 2, 3. Sorry, I've been talking too long. All right, so remember that this is my x and this is my y. Things happen alphabetically most of the time in math. So my x value there is negative 2. All right. Here's the thing about infinity. We never hit infinity, just like when we were doing domain and range. So this is going to be a parenthesis. And the other thing is right here where it kind of maximum, it's a maximum point here, it maxes out. You have, it's kind of like the teeter-totter point. Here we're coming up, here we're going down. It is the point, it's called a vertex or a maximum where we are going to change directions, okay? And so I don't know if I'm increasing or decreasing there, okay? So we don't include it, it's not a bracket, okay? Instead, we're going to say, well, we never quite figured out if it was an increase or a decrease there, so we put parentheses, all right? So moving along, still working with the x values, okay? From here to here is where it was a decrease, right? This section. The y values are decreasing between x equals negative 2 and x equals positive 2. So yes, you have to look, is it going up or down? That's the y. But where is it happening? It's happening when my x is negative 2 here, between there and where my x is positive 2. So as you're reading left to right, you need to come like this. Okay, I did that section. Now I'm doing this section of the x's, negative 2 to positive 2. All right, oops, sorry. Changed colors accidentally there. Okay, and then we say, what about this point here? Is it increasing, decreasing, or constant? Well, again, it's the spot where things change, right? It's like a vertex, but it's a turning point, so to speak. So it's not decreasing and it's not constant. It's neither. So he doesn't get a bracket. He gets a parenthesis. Okay. And when we start on the constant, he's going to get a parenthesis again, right? Because we don't know what's going on at that one particular point. So we're not going to include him. Okay. Now, hopefully that makes sense. We went from negative 2 to positive 2, and then we're going to cover the spectrum from negative infinity to infinity on all of our x values. So now we're going to start here and work our way right. Well, what is this guy? The x value here is 2, right? And how far up do I go on the x-axis? This arrow says we're going till forever, right? If there was a dot here, then I'd need an X value there, right? But that arrow say we're going to forever, so that's an infinity, positive infinity, negative infinity on the left, positive infinity on the right, right? Down this way and up that way. All right, so again, we never hit infinity, so that's a parenthesis. And again, this point right here can't make up its mind which direction it's going, so he is also a parenthesis, okay? There is one more little piece on this, and it's called piecewise functions. It's funny that it's called that. I'm not going to do a lot with it because we'll see more later in the semester, but I am going to just intro it here. So the thing about a piecewise function is it's in pieces. We see it as parts. So a graph of one would look something like this. Here's a piece up here, and here's a piece down here. There's two different parts. I know it's piecewise because I had to draw a piece and then pick up my pen and then draw another piece, okay? So if I had something like that and I wanted to know where is it increasing or decreasing, let's look at this and be careful here. This is, if I carry it with my pen, decreasing, right? Okay, this is all going down. What's happening in the X values there? Be careful, we always do this on the X values. Okay, remember that. Well, this arrow says we're going from negative infinity up to right here, there's a 0, right? That's where it breaks. Does it include the 0? No, because this X or Y axis here is not going through the graph, right? The graph is breaking there. So it does not include the 0. So that is a parenthesis, okay? And then here's the rub. Be careful with this. If I pick my pen up and I come to this other piece and I start following it, what am I doing? My pen is going down. So this is a decrease over here on the left, and this is also a decrease over here on the right. My pen's still going down. The Y value started over, so to speak, way up here at positive infinity, and then they went down. Here the Y values went from 0 down to negative infinity. Here they're going from infinity down to 0. I don't care where the Y values are going. What I care about is that they are decreasing, okay? I'm going to say it's decreasing on the X values. Okay, I always use X values. Okay, so it's also decreasing from 0 to positive infinity, right? Because there's that arrow. And hopefully you know from some of your past experiences that we can union. We can put that little symbol there. And the union means or, okay? So it's decreasing between negative infinity and 0 on my X values, or between 0 and positive infinity. All right. I hope all that makes sense, and that's it for this video. Let me know if you have any questions, and I'll talk to you later.